Okay, in the last two videos, we looked specifically at an octagon that was inscribed in a circle that had a radius of 3. For this video and the next one, we're going to look at just a general polygon. So we're going to call that an n-gon because we're not actually sure how many sides our polygon has. We're also going to say that a circle of radius r. We don't know what the radius length is. Our goal is to create an equation or a formula that we could always use no matter how many sides our polygon has or what the radius of our circle is. So we're going to do this kind of step by step. I did choose a pentagon here. We know that it has 5 sides, but for the sake of it, once again, we're going to assume that we don't know how many sides, and I'm just going to use this to illustrate the points that we're doing. So the first thing, once again, is that we can draw from the center of the circle to the vertices of our shape. Because it is a polygon, or an inscribed polygon, all of the vertices touch the edge of the circle. That means that these two lines that were just drawn in are the radii of our circle. Also, the shape that we've just created is an isosceles triangle. In order to find the area of this triangle, we're still going to be using the formula 1/2 AB sine C. So A represents one side of my triangle, B represents another side of my triangle, and C represents the angle between them. Well, at this point, you can see that I have one of my sides, I have my other side, but I need the angle between them. So because this is a circle, I know that this angle here is going to be equal to my entire circle divided by the amount of kind of chunks or triangles that I can draw. Well, these triangles were drawn by going from one vertex to another, so it spans one length of my shape. So the number of sides that my shape has determines how many triangles I can draw. So we're going to say theta is equal to 360 divided by n. And here n is the number of sides on your polygon. Now if I substitute this in, I get that the area of my triangle is equal to 1/2 r times the sine of theta. We can simplify that a little bit more to get the area of our triangle is equal to 1/2 r squared, the sine, and instead of theta, we're going to put 360 divided by n. What we've just now done is created a formula that will always get me the area of a triangle that I can create between two vertices if I am looking at an inscribed regular polygon. But I want the area of my entire polygon. So in order to go from just this to all of this, I need to multiply the area of this triangle by how many triangles I could create, which once again is based on the number of sides of my shape. So in order to find the area of the entire polygon, I'm going to multiply the number of sides times the expression I already had. So there you have it. Once again, or for the first time, this is multiplication between each of these. It's n times 1/2 times r squared times sine. So this could be written in different ways. This is one way to write it. We could bring the 1/2 out to the front, 1/2 r squared n times the sine of 360 over n. We could rewrite this in a multitude of different ways. However, this expression will now always find the area of an inscribed regular polygon as long as you know the length of the radius of the circle and how many sides your polygon has.